In this problem, we're asked to draw a graph of a uniform density function where x is a continuous random variable between 0 and 20 inclusive. So of my choices in part A, the first thing I'd want to look for is that the length of this function includes a domain from 0 to 20. That does not happen here in choice C. Notice that this graph only goes from 0 to 1, so I would exclude this particular choice. The next thing I want to check is that the area under this density function equals 1. To check this, I'm going to use the fact that this density function is uniform and it is shaped just like a rectangle. And I'm going to find the area of this rectangle by multiplying its height times its width or length. So the height of this function in choice A is 0.01. Its length goes from 0 to 20, so its length is 20. So when we multiply those together, we get that the area under this density function is 0.2. However, it should be 1. So that tells me I can eliminate this choice. When we check choice B, multiplying the height of the density function times the length, we get 1. So again, I'm using the fact that this uniform density function creates a rectangular shape, and the fact that the area of a rectangle is height times width, or length times height, or base times height, however you want to say that. But I'm just multiplying those two dimensions together, and I'm checking that the area under that rectangle is 1. For part B, when it's asking for the probability that x is between 0 and 6 inclusive, I'm now imagining kind of a rectangle within this rectangle, going from 0 to 6. Let's see if I can draw this in here. I went just a little bit too far. So let me erase a little bit of that. So maybe something like this. So if you could imagine here this rectangle within the density function that still has a height of 0.05, and now this yellow rectangle goes from 0 to 6, so it has a length of 6. So I'm going to multiply 0.05 times 6. And that's how we end up with a probability of 0.3. That area that was in that yellow rectangle I had earlier, the area is the same as the probability of x between 0 and 6. So if we apply that same technique to part C, we're looking for a rectangle between x from 10 to 17. And again, what we're describing here is this rectangle. So that rectangle has a height of 0.05. It has a length or width of 7 because the distance from 10 to 17 is 7. I will multiply those two together to get the area under the curve for that, that particular x interval is 0.35, which means it's also the probability when x is between 10 and 17.